Hey guys, welcome on Farming Agency and it's a pleasure to have you. Today I have
Martino?
Martino, from VMG Agro, and it will definitely explain you what is growing on aquaponics. How you doing, man? What's up?
Oh, all good, all good. How's everything with you?
Yeah, definitely. Please, can you give us your background and what is your venture about?
Okay, so yeah, my name is Martino. I'm Cameroonian, and basically my company focuses on the design, construction, operation of industrial scale aquaponic systems.
Okay, from now, please, where is your company based and what is aquaponics?
So our company is based in the US, in Jersey. However, we don't really operate out of the US. We operate in Cameroon, Kenya, India, and then we have a few farms in the works in Serbia and in Taiwan.
Wow. And so, what is aquaponics? Really simple definition.
Simple. So basically, aquaponics is the combination of aquaculture, so that's the growing of fish, and hydroponics. That's the growing of plants without without soil in a hydroponic system. When we combine the two, we're able to get aquaponics and get the benefits of aquaculture and hydroponics combined in one.
So basically, the plants are not growing in the soil. Where are the roots?
So the root, it depends. So now, I mean, so what hydroponics is hydroponics is basically the growing of plants without soil. What that means is that you have, as long as there's no soil, it's a hydroponic system. So in aquaponics, just like in any hydroponic system, you have multiple methods of actually growing plants. So you have the Dutch bucket system, which is used for plants that require a bit less water. So that's now a bucket with gravel inside, no soil, and the aquaponic water is dripped on the gravel, and then the roots now stabilize within the gravel, but not actually bringing the nutrients from the soil or the gravel, but from the aquaponic water. That's one method. Another method, which is very common, is deep water culture. So deep water culture is basically having the plants floating on water, and the roots now are just directly in the water. So this is now primarily the main aquaponic design that we use. And then the last one is NFT. So NFT basically stands for nutrient film technique. So nutrient film technique is basically you have like a tube of maybe like 3-4 inches, and you have the plant inside from the top of the tube, and then at the bottom you have a very small layer of water of maybe 1-2 centimeters that's constantly draining, and the plant is basically pulling its nutrients from that water.
Okay, so when you have your plants that have the roots inside the water, how do you feed the plants the basic nutrients, NPK?
So basically the nutrients now come all from the fish food. So what happens is, so now the aquaculture aspect, the aquaculture component of aquaponics, which is very important now for the growing of the plants, what ends up happening is what an aquaponic system is trying to do is it's trying to replicate what happens naturally in the environment. So what happens in lakes, rivers, dams, and wherever you really have free water bodies. And what that is that basically when you have animals living in the water, such as fish, snails, and all sorts of aquatic life, what they do is when they consume food, be it now from either the fish food or from eating a mosquito or mosquito larvae or anything really they consume, when they now make the excrement is primarily ammonia based. And ammonia is really toxic to both the plants and the fish, right? So what basically has been a gift from God really is what's called nitrifying bacteria. And this is bacteria that even if you were to build a small aquaponic system in your backyard, in your garden, this bacteria will appear there because it's always in the air, it's always moving around, and it's generally found in water bodies. What this bacteria does now is it breaks down the ammonia from ammonia into nitrates, and then there's another bacteria that breaks it from nitrates to nitrites. And that's now the primary source of now the nitrogen now for the plants to basically grow. And then now once the aquaponic system is more established and you get more bacteria cultures within the aquaponic system, you're then able to get what's called demineralization, which is now the further breakdown of the solid fish waste into now calcium, potassium, and all these other micronutrients that are very important for plants in their flowering, fruiting, and seeding stages. Because primarily the aquaponic system is a lot of its benefits can be seen in its vegetative state, but then now once the system gets more established, and you have now more of these micronutrients, you're able now to see much better yields when it comes to now fruiting, flowering, and the other plants that you're not only eaten as just green plants.
Okay, before talking about yields, because it's really important, please tell me, this technique requires a lot of water and huge techniques actually, no?
Well, yes and no. So an aquaponic system requires a lot of water, yes, but no in the sense that the water that it requires is only on startup. Since an aquaponic system is basically a system of recirculating aquaculture, where the water from the fish tank overflows or is pumped out of the fish tank to where the beds of the plants are, and then it recirculates. The only water that's lost is the water from evaporation, which again is minimized depending on the growing method you're using, and really only evaporating at the top of the fish tank. And the other water that is lost is the water now from the actual plant yourself you're harvesting. So what you can see, in fact, the main benefit of aquaponics as compared to conventional agriculture and soil and dirt and different other methods is actually the water aspect. Since aquaponics, you're able to use the recirculating water, you're basically able to save up to 98% of the water. So yes, and at the beginning, for example, in our farm in Kenya, our system itself is around 300 to 350,000 liters. Okay. However, on a monthly basis, our water consumption or our water usage is close to 4,000 liters, which is 1 to 2% of actually the water body in itself.
Okay. Okay.
So with that being said, I mean, yes, you have to fill in your system, but again, over the course of time, you're able to now grow plants using significantly less water, and not actually be dependent on on the rain, you know, or on these other external factors that are really maybe out of your control.
Okay. And what about the yields, please? And do you have a comparison with growing on proper soil versus growing on aquaponics when it comes to the yield?
So before I speak about yields, I think it's important to understand. So like I said earlier, the main benefit of aquaponics for someone who is into the farming aspect of it is the water consumption. You know, as any farmer knows, having adequate amounts of water on their land is crucial to being able to have a successful harvest. So that's the first most important factor, that aquaponics again uses almost 2% of what it would actually be required to grow those crops. Now when we talk about the yields, before we do that, we need to understand two things. Firstly, since this aquaponic water from the fish tanks is so high in nutrients from the nitrates and nitrites, the plants are basically getting everything they need directly to their roots. So what the plants are doing is they're spending significantly less of their time looking for nutrients, which is what they would be doing in soil. That's why when you harvest a soil plant, you notice that there's a lot of root mass. You know, normal plants have a root mass of maybe even up to half or even more than half of the actual plant mass. With an aquaponic system, the root mass is not more than 20% of the overall mass, right? So what that means is that the extra 30% or 40% of the mass is now in the plant. What that means is the plant now is spending more time growing up rather than more time going down looking for water, nutrients within the soil. Okay. So what that does is that cuts down the growth cycle of the plant. So you're able to now get more cycles per acre, per square meter, per plant. So for example, in the case of lettuce, which is what we grow in Kenya and in India, you're able to, so whereas it's in soil, you're able to harvest after maybe what, 12 to 16 weeks, so about 3 to 4 months, depending on the variety. Some maybe a bit faster. In an aquaponic system, we're able to cut that in half, okay, making it so that you're able to harvest in, I think it's like what? I think our cycles now in Kenya are running on about 4 to 5 weeks of them actually being in an aquaponic system. So that means that we're turning over a same square meter as a soil farmer twice as fast as a soil farmer. So that's the first component of the yield. That's very important to understand. Now the second component of a yield is dependent now on the mobility. So what you end up having in a soil system is that once you move your plants from the seedling area to now your actual growing field, greenhouse, or wherever it is you're growing your plants, that's the last movement the plants have throughout their lifespan. However, one thing we do know is that the plants themselves are, when they're moved from the seedling area into the land, the plants are still small, and there's still a lot of space between each plant until again they reach their maturity after, you know, the 2 months, 3 months, or whatever time that is. In aquaponics, the benefit is, since the plants, depending on what kind of growing system you use, so I'm now talking about deep water culture, since the plants are in these little cups floating on the water, what that allows us to do is it allows us to move these plants around throughout their life. Right, so if they have a span of 5-6 weeks, we're able to move them every 2 weeks as they get bigger into a position that maximizes and utilizes more the spatial density. So for example, in our facility in Kenya, per meter square of lettuce, we're able to harvest per cycle, approximately 60 or so, on average, it's about 60 or so heads of lettuce for that same meter square. Whereas if it was soil and we only had one transfer, so in Kenya we have 3 transfers every 2 weeks, where if it was now in soil, you'd only be able to harvest maybe 15 to 16 plants per that meter square. And then now when you multiply these two components together, what you end up seeing is with the multiplication of 2 on the side of the cycle time, and now the multiplication of about 4 to 5 on the, no, not 4 to 5, it's like 5 to 7 now depending on the variety. Talking about lettuce, you're able to now get 6 times 2, you're able to get 12 times this yield per meter square, which now again when you multiply over the over it's not 1 meter square, you add now maybe 50 meters square, you end up being able to get an acre of production of soil in an aquaponic system. 1 acre of aquaponic production is almost equivalent to 11 acres of soil production.
Oh, wow.
The only drawback now to the farmer really is now the setup cost. So the installation cost itself is really what makes aquaponic technology prohibitive, because it's really expensive. However, with these increased outputs, right, what ends up happening is you're able to use the economies of scale to basically be able to recoup your investment much faster, you know. And then now when it goes to tomatoes, cucumbers, and these other fruit and vegetables, what you tend to have is not necessarily using the spatial factor to it. You're able to have now actually healthier plants that actually produce more. So that's now, they produce more and they grow faster. And that's now where you're able to get larger multiplications of growth now when it comes to tomatoes, strawberries, cucumbers, and all these other varieties.
I have 2 last questions concerning first the seeds, because you're producing a lot more. So how do you deal with the seeds? Do you have some plants that you let go until you can harvest the seeds, or you always buying seeds?
I mean, so the debate of the seeds is really a debate that's pertinent to more so what it is you're growing. So when it comes to growing lettuce in our case, and we're planting almost in one of our facilities, we're planting about 10,000 lettuces every week, every Saturday. What ends up happening is that really those 10,000 lettuces ultimately are a cost to us is maybe $15, you know, every week. That's what we're spending. The reason we choose to now actually get to buy seeds every time as opposed to, you know, make our own heirloom seeds and whatnot is not necessarily because we want to save money, but all because ultimately our product is there for 4 weeks to 5 weeks to 6 weeks, depending on what variety it is. And the risk now that's associated with the poorer quality offspring of maybe an initial seed is not something that you're willing to risk now in such a large operation, you know, because now if you end up having a bad germination or bad performing seeds and the seed itself is very cheap, you might not want to take that risk. Where now I understand when you go to tomatoes, when 1 tomato seed costs maybe 250, 300 sefa, you know, and now there's a lot more pressure in making sure that that tomato goes all the way to term. Then now I can understand a bit more the debate of, okay, now let's see if we can try to replicate it. And I think the last thing I want to talk about is the fact that an aquaponic system is intrinsically organic. You know, the difference, there's a big difference that people notice with hydroponics and aquaponics. So it's to understand the differentiation between the two. Hydroponic system is a system where you have the fish tank, you're now directly inserting nutrients and you have no fish. Those nutrients now grow the plants. What that means is your system doesn't rely on biodiversity or an ecosystem, and there's nothing living outside of the plants. So there, in a system like that, you can spray whatever you want to kill whatever pest. When you now go to an aquaponic system, you don't have the benefit of doing that, because underneath the plants or in the fish tank, you have living organisms, you know. So the moment you start spraying something to kill the spider mites and it enters the water and it kills the fish being the battery of the system, you have to now start from fresh. So aquaponics, for an aquaponic system to work, it has to be organic. There's no way about it. You know, so it's by default an organic system. Now, whether it's being classified or not as organic, that's now another debate.
For another time. That was actually the last question. Something before ending. How do you see the future of this type of technology in Africa? You based in Kenya, right now we're in Cameroon, in Limbe. How do you see the development of this kind? Is there a market everywhere? Is there specific countries where this technology can build?
So the main thing, as I said earlier, the main thing about aquaponics is that it's very price prohibitive. So it's not easy for anyone to get into. because it's very expensive from the point of view of actually setting it up. And secondly, the things that you're able to grow in an aquaponic system to have the highest profitability based on yields and market prices are really leafy greens and kind of exotic herbs and leafy vegetables. Those now end up tending to go to markets that are developing a much faster middle class and higher class, because those are now the economies or people that will tend to now eat those produce, as opposed to now a place where it's much more subsistence based and there's also not that much variety on the market.
Okay, and we're talking about how much more or less when we want to do 2,000 or 5,000 square meter aquaponic farm.
So an acre aquaponic farm right now with our newest designs that we've just concluded and what we're using in Serbia and Taiwan, an acre, like a fully fledged aquaponics facility, goes for around, I think it's $250,000 to $270,000.
Okay.
And that full acre. However, that money now ends up coming back in about 2 to 3 years.
Okay.
Depending now on the operation.
On the management and
exactly.
on the selling.
So I mean, it's a quick turnaround, and it's a very cash depending on what you sell. It's a very cash intensive. It's a very good cash flow business to be having in your pocket.
Okay. Okay, that's dope. Please, can you remind us where we can find you? What is your
you can find us on Instagram on VMD Agro Aquaponics, and then our website is VMD Agro Aquaponics. No, VMDagro.com, and then from there you should be able to see our Facebook and you'll be able to see our Facebook, our Instagram from there, and then also you'll be able to see the pages of our different farms and the handles for those different farms. So the Kenyan one, the Indian one, the Cameroonian one, and then now the ones around the ones that we'll be building in Serbia and Taiwan later this year.
Yeah, dope. Thank you very much.
No, my pleasure, my pleasure.
And I hope I will come to see your farm.
No, definitely,
really soon in Kenya.
definitely.
Thanks, my man.